You think some people are born with a secret chip in their brain. You call it talent, genius, a Feynman mind, the thing you don't have. It feels true, because you only see the final result, the clear lecture, the fast answer, the calm smile. You don't see what came before that moment, so your brain fills the gap with miracle. But what if that miracle doesn't exist? What if the difference between you and them is not magic, but something far more uncomfortable and far more useful? Stay with this lecture until the end. Test that idea for yourself. If you want more honest lessons like this, subscribe, like this video, and share it to support the channel. People often think that hard ideas, like quantum physics, need a special kind of brain. It feels natural to say, some people are just born for this, or he has a Feynman-level mind. This story feels right because you see only the result, someone speaking clearly about things that confuse you. You do not see the years of slow work that built that clarity. So your mind fills the gap with talent. But if talent were a fixed, magic thing, then hard work would never move anyone from confusion to skill, and yet it does, again and again. Your intuition measures effort by how it feels, not by what it changes. It tells you that if it feels hard now, it will always be out of reach. To see what is really happening, the idea of miracle minds has to be dropped. When you meet a hard idea, your brain does not meet the idea directly. It compares it to things you already know. If it fits your old patterns, it feels simple. If it does not fit, it feels impossible. Two people can hear the same talk about atoms. One has seen similar ideas before, so it feels natural. The other has no matching pattern, so it feels strange and heavy. The brain uses shortcuts. It saves energy by judging fast, not by checking carefully what is possible to learn. It builds stories, like I am not a science person, or they are born smarter. When many people repeat these stories, they start to sound like truth. But electrons, fields, and small particles do not change because of these stories. They behave as they do, no matter how we feel about them. In real science, understanding is not a feeling inside your head. It is what you can reliably do. If someone says they understand electrons, we do not ask how clear their picture is. We ask, can they use the rules to predict real results of experiments? Can they solve problems and get answers that match what happens in the lab? This means we are measuring actions and outcomes, not inner comfort. That can feel empty because we like the idea of seeing it in mind. But many questions about who is gifted disappear when we look at it this way. The language of I just see, it is misleading. What matters is that their inner model, whatever it looks like, gives correct results again and again. Clarity becomes a tool, not a magic power. Think of a small computer on a desk. You type in how fast a car moves and how far it must go. The computer follows fixed steps and gives you the arrival time. It never sees the car or the road. It only follows rules. Our minds can work in a similar way with atoms and electrons. We can learn the rules for how they act and use them to predict real results, even if we cannot form a sharp picture of what an electron looks like. This analogy is not perfect because humans also feel and imagine. Still, it shows that real understanding is not the same as having a neat image. The picture can change from waves to particles to fog, but the useful part is that the rules keep matching what nature does. In daily life, things act in steady ways. Balls move in clear paths, tools stay solid, hot things cool down. Your mind is shaped by these mid-sized objects. When we go to very small things like electrons and atoms, this training breaks. Electrons sometimes behave like tiny balls, sometimes like spread out waves, sometimes like a kind of fog around a nucleus. No single picture stays correct in all cases, but the rules that describe them do stay the same. Nothing in nature is broken. Only your usual way of guessing has reached its limit. You often do not notice this until you try to imagine these tiny worlds. Then your mind pushes back because it was never built for them. That resistance is expected. The deep rules are steady, even when your pictures fail. When we think about learning, we often imagine a path that goes one way, from ordinary person to real scientist. It feels like there is a sharp line you cross, and before that line you are outside. In reality, the change is made of many tiny steps. Each hour of practice changes your mind a little. Over time, these small shifts add up until the work feels different. You remember the confusion at the start and compare it to later ease, so it feels like a jump. But the same brain can lose skill if it stops using it. The rules of memory allow movement both ways. What looks like a one-way door is just a long series of small, repeated moves settling into a stable pattern. It feels like there should be one correct way to picture an atom, one clear image that every smart person shares. But people reach the same science through different paths. One person thinks of tiny balls, another thinks of waves, another of a cloud or fog. These pictures can disagree and still help each person get the right answers. There is no master image in the mind that everyone must copy. What stays the same is not the picture, but the results, the same rules, the same predictions, the same checked experiments. Each mind slices the same reality in its own way. Intuition fails when it demands one shared inner film of the world. The common structure matters more than matching private movies. Now the idea of a magic, miracle mind is weaker. In its place, you have a less warm picture, minds as changing systems that learn rules, test them, and slowly match what nature does. This is not fully satisfying. It leaves a gap between how strange atoms are and how rough our words and images feel. That gap is important. It shows that language about waves, particles, fog, or talent is always a map, never the place itself. Each new layer of understanding exposes limits in the layer below. If you feel too sure about who can or cannot understand, you stop looking. When you notice that your confusion is now sharper and more focused than before, it means your map, while still incomplete, has become more exact.